Hello everyone, this is Niklas aka Filia, and I want to welcome you to my first video under the name of No Problemo modules. In this video I want to demonstrate my new module, Clips. Clips is a two-stage clipping distortion module made up of a diode soft clipping stage followed by a LED hard clipping stage and featuring lots of other controls, as you can see. I want to start by looking at each of the controls while using only a sine wave from my Doepfer oscillator as an input. Here on the right on the oscilloscope we can see the output of the module, where we can observe any changes we make to the sound. The first four pots can be seen as the gain staging and level control section. First we got the gain hitting the soft clipping stage with a gain of 2. Next is the gain hitting the hard clipping stage with a beefy gain of 30. And at the end there is a output gain stage with another gain of 5 for setting the output level. This gives a total gain of 300 to this module, so let me tell you, this module can easily destroy any signal you want. But with the flexible gain staging you can dial in pretty much any flavor of distortion you need. Once your output level is set, you can use the dry-wet control to blend between the clean and the distorted signal while preserving levels. One row below we can see the knee control for the soft clipping stage, which lets you set the amount of soft clipping. Let's try it out. We can see the sine wave getting squashed smoothly as we turn up the knee. To the right of that we got a control for a feature called resonance, which creates a resonant peak in the signal. The resonance is also controlled by the switch below and is turned off at the moment, so the knob has no effect. Let's turn on one of the resonance settings and turn up the resonance knob. Let's try the low setting. The cutoff frequency of the resonant peak is also affected by the knee knob. This feature can give you a nice crunch to your signal and is highly performable with the switch. Also great for performances is the switch for a high-pass filter. Let's turn it on. Simple on-off switch, you get the idea, nothing fancy here. Below that we've got the bias section, which is a little bit more complex. On the bottom left we've got a bipolar manual bias control. To the right we have an attenuator for the bias CV, which can be fed into the jack below. With the switch we can then decide which of the modulation sources are applied to the bias. In the upper position both sources are applied. In the middle position none is applied. And in the lower position only the bias CV is applied. With the bias CV attenuator set to 0, we will now activate both modulation sources, and now we can observe the effect of the manual bias control. Now let's look at the bias CV. As it can be hard to find the middle or 0 on this bipolar manual bias control, we can easily eliminate any influence from it by switching to CV only here. The bias CV is normal to the input signal itself, as I noticed that it gives a very nice effect, similar to wavefolding when the resonance setting is applied. Above the bias CV attenuator, we've got a switch for controlling the hard clipping section. In the lower position, we got an asymmetrical clipping, using only the upper LED and cutting only one half of the wave. In the upper position, we've got symmetrical clipping, using both LEDs, clipping both waves or both half waves of the signal. The last feature I want to show you is the resonance CV control here. It controls a transistor in series with the resonance pod. So you can effectively gate the effect introduced by the resonance feature if the resonance pod is turned all the way up like it is now. I will now add a LFO to the resonance CV input. Adjust the frequency of the LFO. Okay, this is it for the feature set. I will now add a VCA so I can control the level of the signal itself going into the bias CV, effectively emulating this effect, and show you a bit of the wave shaping capabilities of this module. And after that there will be some more example patches featuring other source material. And yeah, thank you for listening so far and have fun. Okay, so what we have here is my MFB 522 drum computer going into the clips, and from the electron we've got a gate controlling the resonance CV here.